and welcome to this tutorial. We learn how to use the command line interface to do some interaction with the DecBC node. Now I'm gonna show you how to access the database directly, because you may have noticed in the previous attempt of interacting, there is no command to see, for example, the balance of an account. So how do we do this? We go read it in the database. Let me show you how. First of all, we need to connect to our server, SSH root at IP address, use your IP address, not mine, and we connect to the server. At this point, we can enter DecBC, DecBC mainnet, and resources. Remember that here we had the database DecBC.db is SQL database. At this point, how we can interact with it? We can use SQLite tree. SQLite tree may be not installed in your system. It's not installed in mine, so instruct me how to install. So apt get install SQLite 3. Oh, because I forgot the letter S in install. I'm gonna share a secret with you. I got a new Apple keyboard. This is it, and I am using it without unwrapping it from the original wrap. So as you can see, the wrap is still there. This is why sometimes when I type, I miss some keys or some other keys come out funny. Why I'm doing this? Because it's a good way to learn to type exactly on the keys. So I am educating myself. But back to our SQLite tree. Let's install it. And once it's installed, we can use it to access and see the database. So we launch it with SQLite 3 and we enter inside our SQLite. We can use the command .open, and now we need to put the directory. See if we can fit. No, we need to manually enter directory root DecBC mainnet / resource / DecBC.db. In this way, we are getting SQLite tree to work with our database. Now is as simple as to see the help and see all the different commands that we can run with SQLite. For example, tables shows us all the tables. You can see that between the tables there is account balance and node address info, account dataset, many information. So for example, I can run a query such as select all the fields from account balance. We put limit 5, so it's gonna show only the first 5 rows, as we're gonna go down and see a huge list of data. So we can see that there are, the first is 00001, the second is 2 and 2 amounts, then the other are similar. We don't make much sense of this. To understand what the fields are, we can do the command .schema account balance, and this is gonna show us the instruction that created this database, this table precisely, and we can see that has several fields. The first is account address, but is a blob. Blob means is a set of bytes of data that is not readable, so need to be transform to be read. That's why the list starts with a separator and no data before the separator. Block height is the integer number of the height of the block. Spendable balance is how much balance can be spent, and let's not think people has a lot of ZBC, because one ZBC is made of many zubits, we call them. Practically we need to divide in a lot, so the balance is the available balance to be to the account, the proof of participation revenue, and so on and so forth. So what we can do here is for example, go and select specific fields. For example, I can say select. I can request to transform the blob, the binary, into a readable format, and so I can ask X. So select X, make hexadecimal from the account address, which is the first there is a blob, so I make the hexadecimal out of it. Then I can ask let's say all the other fields, okay, from same account balance, and again I can put a limit of 5. In this way I see that the data that before was not appearing, so that was the separator only here and then the rest. Now I have a long string of data. I see two separator because I am getting with the asterisk, I'm getting all including the binary of before. Okay, if looking at the schema I want to only get for example account address, block height, spendable balance or balance, I can simply go there and say account address, block height, and balance. In this case I get the three data separated individually. So this account has the last time it did an operation was a block I2 and has this balance. As you can see, the account is in an hexadecimal format, so you remember the instruction we ran before to transform the hexadecimal into a actual readable format. Let's take for example the last one, this one. Let's copy, let's exit from SQLite, let's go to the previous directory, and let's run the cmd account. What was the instruction? Let's say, let me just check. X the code. So account X the code. X the code had also one particular flag. There was X account address, this one. Okay, so X account address, and then we go get the last one here, okay, and put it here. We execute this and we see that the address in human readable format is this. So let's go copy this and let's go in our Block Explorer and search for this account. Let's see, maybe it doesn't find it. It doesn't find it because it's an account that just got the coin from proof of participation, but never did a transaction in the blockchain. Because he never did a transaction, he would not find it. So let's go search for an account that did transactions. So let's go in transactions. We see immediately that there are a lot of transactions. For example, here there is somebody that received 500 ZBC. Let's click on this, and we see that there is a balance of 513 ZBC. So let's copy this, let's go back to our command line. We do the opposite at this point, so we do cmd account, which was the hex convert, and then the flag, which was the flag for hex convert. You remember, it was encoded account address. And then we can put the account that we found in the Explorer. At this point, we found out the the hexadecimal format for this account is this one. We copy it, we go back in our SQLite 3, we go back to open the okay, this one, so we work with this, and at this point we can query for that specific account. So how we do that? Well, we can do a query such as select. We can put to verify X account address, comma. Actually, let's go back to the previous query that we wrote. Here's the block item balance from account balance. At this point we don't need the limit, but let's say where we can ask for the account address to be the product of hexadecimal number that we copied from there. So in this way it should query the database searching for the blob of account address where the hexadecimal value is this one. And we find that there are several transactions that this person did. So he started with this transaction and then he went down to this transaction. So we should get, for example, not the just block height, but the max block height. Okay, so in this way we get only the highest transaction, which means the latest block where this account made a transaction. So we do max block height, close parenthesis, and here we found which is the last one, where the balance is 207 blah 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 blah. If we go here, we see that there are other higher transactions with different balance for this account, which means that our node is not aligned completely because it stops to this height. But we go check at the block 94082, which should be, here it is, 94082. The transaction is here. We can open the transaction, and it was sending to this 10 DecBC, and there is a message as well included. At this point we can see that there is a match, meaning as a transaction happening here. We need to understand why our node is not up to date to the latest block, but this is for another tutorial where we go analyzing the logs and the error in the peer-to-peer network in the updates. But this is a small explanation how to use SQLite to query directly the database and automatically extract the information for there to the level of update where this node lives and not the latest, and we need to understand why. Thank you for watching though, but what was important to learn was the technique to access the database and query the database. As you saw, there are many tables, so it's up to you to go and do various experiments. You make some good findings, write in the comment and share with us. Thank you for watching.